So hello everyone, welcome to my talk on the role of platform engineering within our greater engineering organizations, and more specifically, how platform engineering can facilitate organizational sustainability. And so before we continue, I'm just going to give a little bit of background on me, and sorry I'm not going to be as moving across the stage as much today. So I'm normally a staff engineer for the New York Times' operations engineering org, usually focused on building platforms for the general election. Right now, because of this, I'm on leave, but that's usually my day job. So as someone who's responsible for the direction of my previous teams as well, so prior to the Times, I was also a tech lead for several teams, both within product and platform engineering. So I spend a lot of time thinking about the function of platform engineering and reliability engineering and how it can facilitate success across engineering departments. And so ultimately what that looks like is coming from the perspective of enabling our department to work in a way that ensures long-term organizational sustainability. And so we'll start off by talking about what I even mean when I say organizational sustainability. And more specifically, I define sustainability as the continuous practice of operating in a way that enables short-term growth opportunities while ensuring long-term success. And there's a lot to unpack here, so we're just going to break it down. And so more specifically, I define sustainability as a continuous way, again, a practice of operating in a way that enables short-term growth opportunities while ensuring long-term success. And so first, right, sustainability is a continuous practice. So even if we spend a lot of upfront time thinking about how to ensure long-term sustainability, circumstances change and often quickly, especially this year in tech, right? And so we need continuous avenues for ensuring this long-term success. And secondly, enabling short-term growth opportunities. Sometimes those risky short-term growth opportunities are what ultimately lead to our long-term success, right? The emergence of bundles of tools, for example, has been a great strategy for many companies. And so we don't want to give those up, right? But putting on my reliability management hat, we also need to prepare for the risk of those opportunities. Which leads us to the component of enabling long-term success. And so we frequently see companies take their core business for granted, often in the name of growth. But for every successful growth opportunity, right, most opportunities do unfortunately fail. And so preparation for this type of risk is going to be essential for our businesses. And so now that I've defined that goal, which is organizational sustainability, let's define the strategy, which is platform engineering. So as much as I hate repeating words on a slide, I'm going to do it, if only for emphasis. So using my definition of platform engineering drives organizational sustainability by practicing sociotechnical principles that provide a community-driven support system for application developers using our shared standardized platform architecture. And so these three highlighted components form the basis of what it even means to provide a platform. And so one theme throughout this talk will be about how platform engineering can enable us to scale our organizations to enable that growth that our businesses often demand. And as part of that, we'll need to ask ourselves, at what point is this platform engineering journey or framework even necessary? And so when we talk frequently about scaling software, right, but what does it actually mean to scale an organization? And the answer is ultimately that our ability to scale our organization is directly tied to our ability to scale our software. And so when we think about scaling our software, right, we have to be intentional about addressing the inevitable complexity that comes with that growth. And to address this complexity, right, we have to bring this intention into how our architecture can enable those needs. And so complexity makes development so much harder, right? It makes things so much harder that we as a collective industry have evolved the ways that we even build applications. So for example, if you're familiar with the modular monolith architecture pattern, it's become an increasingly popular architecture style, especially as an intermediate step towards adopting distributed architecture patterns that will ultimately enable us to do our work and scale our applications. So just like we've evolved the way that we build applications to embrace new architectural patterns, like microservices or other distributed architecture patterns, we must evolve the delivery strategies that we use to build these new architectural patterns. And so if these architecture patterns are a solution to the technical complexity of scaling our applications, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. And so just to summarize it even more concisely, platform engineering is a socio-technical solution to organizational complexity of scaling our applications. And so we'll spend the rest of this talk decomposing each of these components even further. The principles that guide us, the community-driven support that enables application developers, and the architecture that we'll use along the way. So first, we have the principles that guide the rest of our platform. So having focused on reliability management, the principles that we review are going to be very highly influenced by DevOps, particularly because DevOps principles take a strong consideration for both the technical and the social components of what it means to develop and operate software. And so we'll head into those principles next. And so some of us might have heard about the COMS framework, which is basically a framework of principles that should be the core of DevOps organizations. And so while all 5 could be easily applicable here, we're just going to focus on 3, specifically culture, automation, and measurement. So starting off with culture, the COMS framework tells us that DevOps drives a culture of continuous improvement and reduces silos by intentionally sharing knowledge and feedback. And so the same here is true for platform engineering, but I'll talk about it a little bit more darkly by putting it in the context of community. And so in DevOps, right, we often talk about breaking down silos, and the way that we break down those silos is by sharing knowledge, right? And this means that to share knowledge ultimately means to connect. And so connection and communication, right, are going to be key for preventing the silos that would otherwise hinder our ability to make continuous progress. And so when we're talking about organizations, especially as our organizations grow, the most effective way to manifest this culture at scale is to think about how we can manifest this culture at scale. And so ultimately, right, the opposite of isolation is to be in community with other people. I assume that's why a lot of us are here today. And the reason that that's so important is because more than anything else, right, learning is the most important advantage. It's most sustainable advantage. And so this quote is by Andrew Clay Schaefer, who is often known for being the co-founder of Puppet. And so he said this in his talk on sociotechnical systems at DevOps-based Amsterdam last year. And the way that I interpreted this to mean is that because our industry is always changing, being able to keep up with this change is the biggest advantage that we can actually give ourselves. But again, to do that, right, learning needs to be a part of our organization's DNA. And so while I agree with him, I'd like to modify this a little bit to emphasize that communal learning is the most sustainable advantage. Because while our individual growth is important, if this knowledge isn't shared intentionally, then we risk introducing singular points of knowledge. And so like our technical systems, right, humans, we're not supposed to be 100% reliable. And so we shouldn't be putting anyone in the position to be singular points of knowledge. Speaking personally, right now I'm on leave. Can you imagine if I was a singular point of knowledge during the general election year? So, right, this is how true live way to do the bus test, or there's got to be a less dark way of saying the bus factor test or whatever. But so this is how silos are created, and this is ultimately how silos become an organizational pattern that hinders sustainability. And so, right, in other words, communal learning is what provides the knowledge redundancy that is needed to sustain both ourselves and the business. And so next, we have automation, which improves our software delivery processes by reducing human error, improving our efficiency, and enabling faster delivery. And so this means thinking critically about the type of work that doesn't require business-specific knowledge and figuring out whether that work can be consolidated into software that's managed centrally by platform engineering teams. And so in this, right, we can reduce the required cognitive load that product engineers often have to indulge in by managing all aspects of their software. And the type of work that's important but can be consolidated away in an automated or centralized way is work that's repeatable or manual, which is what SRE will often refer to as toil, or what product engineers might refer to as boilerplate software. Another aspect of platform engineering is how we should be explicit about improving efficiency by leaning into solutions built by third parties, whether that's through vendor solutions or open source ones. And the reason for this is because we need to reduce our own cognitive load just as much as, and maintenance burden, just as much as product engineers do. And lastly, we have measurement. So let's talk about the function of measurement, which is ultimately to have feedback loops for whether our work is actually having its intended impact. And these feedback loops consist of both quantitative and qualitative feedbacks for continuous improvement. And the way that this principle connects to sustainability is, again, by eliminating time spent on work that doesn't ultimately lead to our business goals. So for example, right, if a tool that we spent weeks on isn't actually serving our product engineering users, which leads to lack of adoption, we've now invested time that could have just directly served our product end users. And so we end up just missing the ultimate goal of building applications that age well with evolving product growth opportunities. And so in other words, right, these feedback loops just keep us on the right path towards the continuous improvement that enables us to build new features, again, while maintaining our existing software. And so now that we've defined the principles, we'll shift over to talking about the support strategies for application developers integrating with our platform. And so we'll speak to both scalable and flexible strategies and put it in the context with the ways that we measure success, consolidate efforts, and cultivate a culture that values sustainability. Now, the first is the most scalable strategy at all, which is to make building sustainable software easy. Seems pretty obvious, but we'll deep dive this one into more in the next section when we talk about our platform architecture. But just to set the stage a little bit for that, let's remember from earlier that sustainable organizations are directly tied to their ability to build sustainable software. And so I'm sure we've all worked with software that clearly wasn't built with much foresight, right? This is usually what we refer to as tech debt. Or legacy code. Tech debt, right, is inevitable. But we can mitigate its risk by being intentional and strategic about when and where we inject this tech debt. Right? Ultimately, it should have a function, usually for the purposes of those growth opportunities. And tools that aren't easy to integrate with are a type of technical debt that typically doesn't pay off in the long term. And so, as platform engineers, it's especially our duty to build easy-to-use tools that minimize the time that we need spending to support application developers. Now, that's not to say that we shouldn't be willing to support developers, right? The opposite is true. I've mentioned this throughout the talk. But just because platform engineering is supposed to make domain boundaries clearer and decouple product development from supportive tools, that doesn't mean that we get to just stop working and talking to one another, right? And so I know, speaking maybe for myself and maybe projecting onto other engineers, I know as engineers we often have an aversion to social interaction. But people are supposed to interact with each other, right? And I mean, I think the pursuit to make everything self-serve has been actually more harmful than it has been helpful sometimes. And so what we really need to do is be intentional about when the right time to support is and how we can leverage a culture of communal learning and support so that the platform engineers are not the singular points of failure or knowledge that I mentioned earlier. And so not only does this alleviate some tension on us, but it enables us to be community-driven in a way that we can support product engineers. And so we talked about measurement briefly as a principle earlier, and an important measurement of our effectiveness is the adoption of our developer platform. I'm sure you've heard about this throughout today. So what intention looks here is ultimately defining the ways that we approach support and clearly communicating it to avoid the mismatched expectations that will ultimately degrade trust between platform and product engineers. And so in the interest of time, I'm going to only provide one example of this, which is to provide an easy decision framework driven by the status of your tool. And so this clarifies a lot of the ambiguity that we often see around release deadlines or feature improvements, et cetera. So a common pitfall for platform engineers is to take on too much platform integration work. So like the last slide showed, there is room for that, especially in the early experimental mode, but it's not scalable, and therefore it's not sustainable, especially for those larger organizations with hundreds or more engineers. But again, that's not scalable, and therefore it's not sustainable, and nor are we even often the right people to be integrating with applications that we have no context with anyway. And so one example that might be relatable here is testing, right? So platform engineers can certainly create or recommend testing tools or methods, but we can't be the ones that are writing unit tests for production services that we don't own. That requires domain knowledge, and luckily if we're doing our jobs right, the time that we save them by providing support frees up product engineering time to take on more application-specific work. And lastly, driving a sustainable culture. So sustainability doesn't just apply to software, it applies to people, and the two are very closely tied. I believe Hannah will elaborate a lot on this after, so stay tuned. And so referencing Accelerate, it talks about self-sustainability and the different types of burnout to look for, whether that's physical or emotional. Because platform engineering ultimately naturally touches all, if not many, parts of our organizations, we also have a unique opportunity to show what it looks like to operate in a way that achieves excellence without sacrificing people along the way. And so again, our work is naturally collaborative and can impact so many parts of our organization, so we should drive this culture of intentionality forward with everything we do. And lastly, we have our platform architecture, which is the architecture that platform engineers are building to support product development. And again, the function of this architecture, it ties directly to the first support strategy we talked about, to make building sustainable software easy by reasonably consolidating efforts and cognitive load. And so we've already talked about our high-level principles, but next we'll review a couple of architecture design principles. But first, I'll actually get water. Oh, no. So the first is to embrace design-driven architecture as a core set of best practices. intentionality should be an important attribute of the way that we build applications and technology, and how we collaborate with others. And so this intention should manifest in the way that we design platform systems, whether that's to use concepts like abstraction and modularity to support different functional concerns. And so this principle can be broken down into many pieces, but I'll omit that for now because we'll talk about this again in design tensions and how to alleviate them in a few minutes. And secondly, our architecture should be complementary to those of our users. Now, that doesn't mean we shouldn't try to anticipate developer needs. There is a value of thinking about where our platform architecture might be heading, right? That's why we tend to have these periods of setting vision and strategy. But to the last principle on intentional design, we need to design with the future in mind and not necessarily build for it immediately, much in the same way that we might design a monolithic application in a way that would enable us to decompose it into a distributed architecture in the future. And so when we prioritize our work, we should be driven by the needs of application developers in our organization, whose architecture should be a reflection of our paying end users. And so that might lead to prioritizing and deprioritizing certain domains, whether that's CI/CD or observability or runtime language support. And within those domains and problems you're trying to solve, you'll also need to build in a way that's responsive to evolving architecture and development needs. So for example, if we want to improve the runtime experiences of developers, we should prioritize the languages that are actually used by them, not just ones that we want to support because we love this language more. And so, right, this is because ultimately we're not here to tell developers what to do, we're here to support them in what they need to do. And another reason that this is so important is because our platform architecture can easily lead to what I call platform chaos. And so every time I say this every time I give the talk, I hate the slide, right, because we don't want that. We don't want to, I'm gonna knock this water over at some point. We don't want to live in a world where we have 10 tools or platforms or whatever you want to call this mess for any given thing that we want to do, right? Unnecessary drift is painful. And so an overwhelming number of tools, especially custom ones, it's not the goal, right? Tools are just enablers of our goal to build successful engineering organizations. And so instead, see, everyone's dropping stuff. Instead, we need to be managers of chaos. And the way that we do that is by aligning the components of our developer platform with specific domain use cases. And so this enables us to design our platforms so that we see the similar benefits that we see in microservices, or end-user-facing architectures, rather, which is concrete separations of concerns. And this is where I'll take a moment to talk about a common pitfall that we see also within platform engineering, right, which is that platform engineering is not equal to infrastructure platforms. And I think this is often why we have some conversations about DevOps versus platform engineering, because a lot of us are operating under the assumption that the only shared platform that companies need are ones that are limited to infrastructure. But for example, right, we should be also thinking about how platforms can aid the service or feature development cycle during the actual development process. And that might mean having language runtime platforms that support development of standardized Node.js services or whatever your language of choice is for your organization. And each of these, again, can be decomposed even further. But again, tying back to principle number 2, we should only do this decomposition if there's a genuine need for it. So for example, right, if our organization decides to introduce a new standard language, then that's probably a good moment that we want to decompose our runtime platform. And in the infrastructure platform context, we might also see this further broken up into domains like cloud infrastructure, CI/CD, or observability. And the same technique that we see in domain-driven design are also the ones that we want to reuse in the platform context as well. And just to complicate this even further, right now there are even product platforms, which we might refer to as a specific end-user product domain or a core platform. Sometimes you see this as core services. It depends on your organizational structure. And lastly, choosing boring technology. And so this ties back to when I spoke about not building tools from scratch. And we can prevent that by not leaning into every cutting-edge opportunity that we have. So some years ago, a blog post named Choose Boring Technology by Dan McKinley went tech viral. And he talked about this idea of innovation tokens and how we need to be intentional about where and when we spend those. Engineers, I'm guilty of this too, right? We love to play with new toys, right? But every proof of concept shouldn't be making it to production. And I acknowledge, right, this is super tempting, right? Everything that the CNCF, for example, is super cool, all the standards and whatnot. But recency bias shouldn't be driving our decision criteria. It should just be informing it. And one of the most seen as boring technologies is documentation. And so sometimes this is considered a hot take, but too many internal developer platforms can honestly be replaced by good best practices and standardization docs. And no, right, it's like not as exciting, but it's still work that enables us to learn and mature how we build technology. And like even if months or years later you decide that we do end up needing a new tool, it's still often not wasted effort because they often end up being pretty good starts for design and requirements gathering anyway. And so I mentioned earlier about some design tensions related to architecture best practices. So we'll review these next, including a framework for how to address those 4 primary tensions. So first we have what I think is the hardest tension, which is standardization versus flexibility. And so the shared nature of a developer platform is an awesome opportunity to reduce the risk of drift. But we have to hold that in tension with the flexibility that our developers might need, especially as our organization grows and the number of technical needs grows with it. So for example, in the past, I've had to deal with the consequences of building tens of services with an opinionated framework that had since not aged well. And so not only did we have to revisit how we approach runtime support, but we also have to reconcile the tech debt that manifested from this decision many years ago. And so that said, reflecting on where we went wrong, but what we ultimately shifted to, is to engage with our users more. And so I started this talk by saying the opposite of isolation is community. And so now, then we approached it from the standpoint of driving standards with actual teams and from the learning communities of practice. And so next we have the tension of simplicity and complexity. So as we respond to the evolving needs of our users, complexity can become a lot harder to manage because the architecture that supports them is likely to change, whether that's to begin using event-driven communication patterns or begin embracing client-side rendered front ends. And so again, this becomes another area that we need to be intentional about. And so like tech debt, complexity is inevitable, but we can compartmentalize it somewhat by making sure that the developer-facing interfaces are simple, which leads to the most common source of complexity in software engineering, which is often integrations. And so we know the common design principle of reducing coupling between services, right? And the same applies to our work. Integrations are often high risk because avoiding coupling is incredibly difficult, right? That's why a huge selling point for some of our vendors is their integrations. And so that's because we don't have to think about that now, right? Oh no, what did I do? There we go. So speaking of vendors, remember our automation principle from earlier. Even though I just spent some time talking through design principles for building platforms, I'm also here to say, give yourself permission to not build at all. The decision to build versus buy versus reuse should be our bread and butter, and deciding that we don't want to take on the work of building and maintaining a tool is a very valid one, because as one of my mentors once told me, like every line of code that we write is a liability. And so code is supposed to be our bread and butter of platform engineering. Research and design and technical decisions are. And this is because engineering is a craft, and so we should treat it as one. And so holding all these tensions in mind, let's talk through what I refer to as the platform framework. So this framework is reusable and has 4 pillars, and they allow us to enable, compartmentalize, or communicate the trade-offs of the tensions we just talked about. And together, they make up our ultimate developer platform architecture. And so we'll briefly review each of these pillars and then provide a couple of examples. So first, we have the parts of our architecture that provide standardization. So 2 examples of this might be through templates or opinionated frameworks. Secondly, we have the parts of our architecture that provide more flexibility. For example, we might design our framework to be more modular so that developers can just pick and choose what's needed for their context. And thirdly, we have the parts of our architecture that compartmentalize complexity through integrations, since the first 2 pillars reflect the simple interfaces that I mentioned earlier. And so this might be APIs that tie the first 2 pillars together, or plugins to front-end interfaces that developers need to use to provide visibility into our internal developer platforms. And so these tools are often not directly used by developers in their development, are instead tools that we use to support developers in an automated way. And lastly, we have the parts of our architecture that communicate our design and decisions along the way, whether that's API docs or decision records for when we decide to build versus reuse versus buy. And so it might feel a little bit strange to have this be considered part of the architecture, but as I've emphasized throughout this talk, right, like touch points between platform and product engineers are essential. Documentation, first obvious one, with support channels as a complementary. So there's also a potential need for automating certain aspects of our support as we scale up the number of engineers that we're supporting. In the integrations pillar, I mentioned plugins as an example to provide visibility of what tools exist. And this is an essential question to answer because visibility is needed to drive adoption. And so how do we provide this visibility? So especially with the emergence of Backstage, which is an open source project by Spotify, developer portals have become a way to provide centralized visibility into the developer platform ecosystem. And so the concept of developer portals is a compelling one, right? It tells the story of what it ultimately means to develop software at your company. And so by providing this unified view, not only does our platform become visible, but it also facilitates visibility into any service that's using that portal. And so integration are going to be a crucial part of developer portals, but because it's a centralized entry point, we also do have to consider the risk of a singular point of failure. And so this is why it embraces plugins, which are designed to be easily added or removed from the host application without total coupling. And so in other words, just as we saw in our principles, it provides similar benefits that we see with microservices by having concrete separations of concerns. So now that we've covered some of the fundamentals, we'll move on to this end-to-end example of what platform engineering might look like in an organization. And so what platform engineering might ultimately look like is around the feature development cycle. I'm not going to go through each of these in the interest of time. All we need to know here is that this is the story that we're telling, the one around our feature development cycle. And the ones that are going to be most relevant to us are the development, production readiness, and delivery stages. So this is what will be best reflected in the next few slides. So the specific end-to-end use case we'll review is around this life cycle of a service, focusing on the flow that reflects what it would look like to build a new service in an organization. So starting from the left here, let's say as a product engineer, we're building a new backend service in an organization with a fairly mature platform, which is why you see some of these components here that I didn't necessarily mention before. And so to get started, right, you as a product developer enter the developer portal integrated with an artifact manager, select a bundled standardized service template, enter details that are application specific, and then an API integration that platform engineering teams own generates that service using an integration with GitHub. Now you're ready to develop your service, and depending on our needs, you might utilize even more modules or just use framework features. From there, we'll continue to use GitHub, either directly, but now we can also do it through the portal, until the PR process is done. And from there, we enter the more delivery-focused part of our platform, and that bundled service template that we use to generate a service also includes config templates that the CI stage can use to build, test, perform static code analyses, et cetera. So now we only have to worry about choosing good values and modifying a values.yaml file, for example. And since our portal includes a drone integration, we can easily gain visibility into each of these steps, which is especially useful for when they fail. And as a best practice here, platform engineers should be very intentional about making it clear when CI/CD pipelines are failing because of our tools versus they're failing because of an application bug. And if the CI stage happens or passes, a CI integration will then push the build artifacts that are generated in that stage, providing access to the rest of our stages in our pipeline. And so these artifacts can be used in continuous deployment to perform things like infrastructure management and pre-production testing. Then, using GitHub or a portal integration, we move on to tasks related to release management, like approvals, release tagging, et cetera. And so after successful testing and approvals, the service is deployed to production using similar mechanisms as we saw in the CD stage, but with more additional safeguards. And finally, we've concluded the delivery process and head into maintenance mode, which is supported by the tools that we provide to observe and monitor our systems. All right, I know I breezed through that last section, but before I conclude, I want to bring us back to where we began. So to wrap this up, I've made a lot of parallels between DevOps and platform engineering throughout this talk, and I hope it's obvious how important DevOps has been to the discipline, much in the way that it was for SRE. And so our systems are complicated because people are complicated. And much like architecture design, this type of culture doesn't just happen. It requires a lot of intent. And I think the most compelling part of DevOps is ultimately the way that it transforms our culture to be one that fosters exactly that, intent. And so I started off this talk by saying platform engineering is a solution to building sustainable organizations, but perhaps the solution that we really all need is actually just intent. Thank you.